Welcome to Stay Sharp in Digital Engineering, the podcast that sharpens your understanding of digital innovation for products and manufacturing. In this episode, Jonathan Scott and I have in Fernando Valera from Visure Solutions as our guest expert to explore the intersection of PLM, ALM as an applications lifecycle management, and requirements engineering. We cover hardware and software integration, systems and engineering, MBSE, digital twins, and AI's role in transforming requirements management and product development. Let's jump in. Welcome back, everybody, to Stay Sharp in Digital Engineering, the podcast about all things digital related to products from engineering to manufacturing, service, and more. I am one of your hosts, Juliann Grant, and I am joined today by my co-host, Jonathan Scott.
Hello, everybody.
Hey, Jonathan. It's always good to see you.
Yep. Good to be back. Another fun conversation. Yep.
Indeed. So today we are talking about a very interesting topic. I don't know if we've covered this too much in the past, so we're looking forward to having this conversation. So we're talking about one of the great intersections of systems and domains that challenge a lot of product makers today. So which is how requirements, software, and hardware all come together. So most products today are cyber-physical, meaning they have mechanical, electrical, and software requirements. But it's tough to put that kind of complexity together without being purposeful about your requirements and how you validate and manage those requirements as you go. So how does this all fit together? And PLM and ALM and requirements engineering. So that's what the conversation is about today. And we have a special guest with us, Fernando Valera from Visure. Welcome, Fernando.
Welcome, and thank you for having me.
Yeah, we're really glad to have you here today. I think you're a perfect person for this conversation. Let me give you a little background on Fernando. He is part of the founding team of Visure Solutions and currently holds the position of Chief Technology Officer. He relocated to Silicon Valley in 2012, and he leads the development of innovative solutions for safety-critical and regulated environments, primarily in the space of requirements, test and risk management, and product development. And with more than 20 years experience in requirements management and entrepreneurship, he works closely with customers worldwide to solve the needs of complex product delivery. And more notably, I thought it was interesting, in 2010, he became a certified professional in requirements engineering, CPRE designation by the German International Requirements Engineering Board, which entitles him to provide CPRE trainings worldwide. So highly qualified for this conversation, and thanks for being here.
Yeah, absolutely. So glad to have you, Fernando. And with that, I want to jump in, right? I just want to get right into this topic because it's a good one.
Make me shut up. Yes.
No. No, but I've got questions, right? And when we get
you do.
When we've got a guest like this, I've always got questions. So our audience is probably familiar with most of the systems and acronyms we're talking about, but maybe not all of them. So I just want to do a quick rundown to sort of set the stage. So, okay, Juliann mentioned PLM. PLM is Product Lifecycle Management, and that's the system that's often used to manage the data about hardware products, right? Ideally, through the product's full life, that's the lifecycle part, including from concept through design into manufacturing, service, and retirement. Okay, ALM, a lot of people, you can kind of think of that as an analog here, like it's application lifecycle management. So let me just differentiate there. There's some ambiguity. It's not asset lifecycle management. So those listening, if you're into the plant world, you may be confused. So we're talking about application lifecycle management here. But it's sort of an analog, right? It's the system that people are using to manage the data about software products, right? So if PLM's hardware, ALM's software, and ideally it's through the product's full life, including from concept again, through design, but not manufacturing, right? Development, testing, and support. So kind of a different life cycle, but nonetheless that full life. The third one I want to bring up that'll get us right into our first question is requirements engineering, or RE. It's the process of capturing, managing, and tracing requirements, and probably a bit more. But what can be confusing about this is that some PLM and ALM systems include functionality for RE. But many organizations, even those that have that functionality in their PLM or ALM system, still use separate requirements engineering tools. So that's some of what I think is worth talking about today. So first off, let me start there, Fernando, with those kind of definitions, laying that groundwork. How would you extend or shape or challenge even my definitions of those things in terms of what we're talking about?
Yeah. Well, I think that was a perfect introduction to make it very clear for everybody what this PLM and ALM mean. Basically, those two areas, hardware and software, have worked as separate silos. And the teams have not collaborated that much together. So they've used different methods, techniques, and tools. Whereas at the beginning, the conception phase is where they have a common ground. And that's where the requirements engineering, systems engineering take place, and then they stem off. I would say that the main difference between both of them is the cadence that they have. So hardware is more stable, less releases, whereas software, it's just like the crazy guys running in circle with hands in the air, releasing versions, stressed out, So that requires a whole new set of needs in terms of requirements. Like, okay, what did we implement this week? It's like, oh, no, that was implemented the previous week, right? Where was this documented? So that took a lot of the tools to mature in terms of the requirements engineering process. So, let me stop you there for a second, Fernando, just to make sure the audience kind of has a conception of what you said. So I think it's a really important point you made. Those cycles are very different, right? In hardware, it might be, we're working on things, and at the end of a month or end of a quarter or even, 6-month period, we've got some iteration of what we're doing. Whereas on the software side, you're talking like, well, yeah, it's weeks, or a week or something like that. So it's that kind of cycle. And that's what's driven I think where you're headed next is there's some difference that you have to deal with when you are working at those different speeds. Exactly. So conceptually, it's always the same. Writing down what is it that we need to do, and then make sure that what you implemented is what we wanted. We're good, right? However, the processes that are being followed, especially when teams are implementing Agile, require the management to be done in a slightly different way. And that's when the different tools deviate in terms of functionality. So I would say that ALM tools take care of the whole software lifecycle, but it will depend on the type of process that you're following, the type of industry that you're following, the features that you will get in those tools. That's why it's kind of sometimes foggy, the term ALM. We all know that it's for software, but I've had conversations with PLM tools saying like, well, we've been looking around. So really, what is ALM? What does it include really, right? So requirements for sure, test management, risk management, traceability to the source code. So I would say that the requirements is a fundamental portion. It's the starting point for both of them. But the capabilities and the requirements for ALM will go a little bit further than the capabilities and requirements for PLM, traditionally speaking.
And are they, you mentioned governance, and that brought up the word Agile, and that I think that leads to an important question. Does the type of governance you're going to have on your project or whatever you're doing to develop a product, is that going to matter in how you do your requirements engineering and how these tools need to work? For instance, if you're Waterfall on hardware and Agile on software, does that mean, these need to be different processes, or how does that look?
Yeah, absolutely. That's a great question because traditionally, people have thought that they have to be two different processes. They had even different tools for each one of them. And what we found among our customers is that they have a big need to join those two processes together. Yeah, so for instance, I would consider the requirements engineering as an overarching activity where both ALM and PLM stem from, right? And you have to be able to have the tools that will adapt to whatever process you're following, whether it's an Agile or traditional V life cycle. But you need to know that everything has to be traced, right?
So it's not necessarily that it means different tool set or functionality on the requirement side, but you do have to think about that. Like, how's it all going to blend? What's the process going to be? But it's not like, there's requirements for Agile and there's requirements for Waterfall and there's requirements for this. And so it's not like that's all different flavors.
Yeah, exactly. I think it's just a matter of deciding, making sure what we do, establishing the correct methods and tools, especially in terms of tools as well. Some tools are very focused for let's say, PLM and don't support like the Agile world, or some tools are very Agile and they don't support the Waterfall. So making sure that you get the right tool in place is going to be fundamental for that.
Okay. I think about this point about how you use these together, and I do see this challenge with a number of customers, right? Wondering that, trying to figure out what is the answer to this. And when I think about how to use the tools together, first off, it's a small set of customers because lots of people are focused on one or the other, and they're trying to bring in the opposite one, and then think about how to do requirements across all of them. But when I think about putting all of that together, I feel like there are a lot of challenges. Right. And I've got some of my own opinions on this, but I want to sort of set that stage for you. What do you see as those challenges around bringing requirements engineering into the mix of having both systems, maybe having a third because of how you want to focus on requirements engineering? What are the challenges with all of that?
I think that there are different types of challenges. The first one is the cultural challenge. So we can adopt tools, but making sure that people change the mindset of working from a product perspective, not from a silo, or you're not a hardware engineer. You're just enabling a portion of the product, right? People tend to think in their box, but there's still a small box of the system, right? And that was very shocking for me since the beginning of time. These are the software guys, and they barely talk to the hardware guys. They only talk when these guys do something and they mess up the system, and that's
right.
That's when
someone gets mad, and
exactly. And then they talk all that they haven't spoken in a while, right? So that was
it's like interfaces rather than collaboration, right?
Exactly, precisely, right? And so that struck me since the beginning of my career, right? So just as an example, we try to fill in that gap so that requirements can be used by all the teams, regardless of the type of system they're building, or the type of component they're building, hardware, software, or whatever else, right? So I think that mindset is one of them. Also, making sure that they're choosing their correct methodology and that they blend in all the methodologies. It's fine that you work on an agile, manner, because it's great, it's really cool, modern, and everybody loves it. But it's not for the sake of doing agile. You're, again, part of a bigger process. And perhaps from a product perspective, you cannot be delivering a product every 3 weeks, for instance. So somehow that software development has to align to a high level cadence of the product and the rest of the components, right? So you have to define a product process and then aligning those process components with that system process.
That one makes a lot of sense to me, right? That there's sort of a hierarchy of process, right? At the product development level at the top, and then hardware and software could have their own cadence or process or whatever, but you have to think about how it all blends. Otherwise, you kind of end up with a mess and you're missing the overall schedule.
Exactly.
And I'm wondering, is there someone who helps lead that? Is a certain kind of person that helps lead that? Or is it the software that helps align that?
So I would say that the biggest leaders in that sense have been the system engineers. It has been an underrated role for a long time, in the sense that software engineers or hardware engineers, the actual engineers had a lot of saying in what the process would be. But I think system engineers is becoming a prominent role. And we will speak about other areas where I think the system engineers are taking a lead role or a leading role in there. But I think they would be the ones making sure that all this makes sense, right?
All right, so that tees me up, Fernando, for a perfect question.
Does.
I've been itching to ask this one since the beginning, right? So we talked about PLM, we talked about ALM, and we understand that requirements engineering fit, right? That it fits in both. You have to think about that. Okay, so you brought up systems engineers. That makes me think about MBSE today, right? And model-based systems engineering, for those folks that aren't familiar with that term, right? This is a relatively new approach in systems engineering, last 10, 15, 20 years, something like that. But the idea is, we're putting things into models instead of documents to describe systems architectures. Of course, that's very closely related to requirements engineering and also closely related to software products and hardware products. So it fits right in the middle of that intersection we were just talking about with those challenges. So from your perspective, where does it fit into all this, particularly like in a systems framework? Does that MBSE, do those models belong in PLM or ALM or in requirements engineering, like RM tools? Or is it a fourth piece of this integration? Or, take me through your view on that. What do you see?
So I would say it's again, at the requirements level, an overarching piece of the puzzle, right? The MBSE, the SE part of that word is fundamental systems engineering, right? It's model-based, but at the end of the day, it's systems engineering. It has been done through requirements in the past. So what this comes as is as a help to reduce the complexity of thousands and thousands of pages of requirements. So the DoD at some point said like, hey, it's crazy that we have thousands of pages that when we want to make changes, it takes months and months to analyze. So we have to reduce the complexity of this. And they said, okay, let's do models and let's see how this works out. The mixed experiences, it took a long time for it to pick up. And the reason is that models have traditionally been used in software extensively. But this is a completely different level because it's systems engineering, right? So not only software guys, but hardware guys had to all of a sudden understand the models. And they were like, well, what are we talking about here? I don't even understand this. And that created a little bit of a rejection. So now a lot more people are understanding the models. The standards are evolving. And the MBSE, and my latest experience, right? Because humanity tends to go from one extreme to the opposite extreme to end up getting somewhere in the middle, right? So at some point, everybody was like, we will be able to do everything with MBSE. The reality is that it has to be a combination between models and requirements. They coexist, and the result of both of them give way to ALM and PLM, right? And those models will eventually translate into the components, right?
So I want to come back to something you said. I think you're touching on it right there at the end about how we swung one way and back to the middle. That initially, when you were answering my question, you said, when DoD looked at these thousands, tens of thousands of requirements, they said, look, something's got to make this easier, less complex. And MBSE can do that. How do you see that it does that, right? I mean, I see a connection that, well, when you have a model, suddenly you can start to do allocation, and that's sort of a compartmentalization, and that's how you get to reduce complexity, is what to deal with in the right context instead of being overwhelmed. But is it that, or is it something else? What did you mean by that reduced complexity?
Mm-hmm. Yeah, very, very good question, because it's sometimes not clear, this aspect. It's actually very foggy, and I see many organizations thinking that MBSE is just using models, and it's beyond that. It's just making sure that the system itself is contemplated from different perspectives. Imagine, let's say a perspective is the performance of the system or the aerodynamics. And for the aerodynamics, you can imagine a diagram, right? Or if you're thinking about the design of a building, you will see like the 3D model. And nobody thinks about somebody typing in text what the building is going to look like, right? So the MBSE is basically providing a simplified view of let's say, a facet of the system or a perspective of the system that is very simple to understand. So first of all, the communication is one of them. And then the second one is the fact that we can articulate different perspectives at the same time. And then we can actually connect different perspectives. we also have to be very careful of not overusing them or underusing them. That's kind of like the hard part of it, right? But I think the absolute key aspect coming from the use of model-based systems engineers will be the simulations. So articulating the models, whereas text in requirements didn't seem visible until we got AI.
Right.
Now that we have AI, we can actually take a text or a set of requirements that could act as a prompt and then simulate them. But up until this point, we were like, okay, we have models. We can kind of execute the models to do something, right?
Yeah, I think that is an extremely powerful part of MBSE, to your point. There's sort of the static models of, okay, here's the model of the system, here's some behavioral elements of the model, right? And those connect back to requirements. And then we can get to the performance aspects with the parameterization part of MBSE and say, okay, let me do some calculations. But then it gets really interesting, to your point, when you take that parameterization and say, let me do simulation. Let me go outside of the model in the MBSE tool and get to a richer, I'll use the big word here, phenomenological model, right? Like, so some kind of scientific phenomenon, but those sorts of simulations, you plug it in and suddenly it's like, wow, now we've got something really interesting. So I get your point about those are all elements that mean you can take away some of the complexity of your 10,000 requirements by looking at them differently through that lens of MBSE.
Exactly. And I think there's another shift in the market that has been driving this improvement, and has been the improvement of digitalization and the creation of digital twins. So in the past, in order to iterate in the hardware part, the cadence had to be much longer because you had a physical part and then you tried it and tested it, verified it, whatever. But right now, with the fact that we have digital twins, and to a certain extent, we can rely on them as representations of the real world, but in digital, we can actually improve or expedite the cadence of the hardware as well, or the mechanical pieces at least. So software has reached its limit in terms of cadence. Things are accelerating, but still,
yes.
I think the hardware will accelerate a lot more, and we'll get iterations much faster. And now the PLM world is facing the issues that the ALM world faced like 15, 20 years ago. It's like, oh, we have a lot more iterations. What do we do with all those changes? Oh man, but we have changes like on a weekly basis. What do we do with this? It's like, don't worry, we got you.
We sorted this out. We can do this.
We've done it.
Exactly, right? And I think the MBSE is tying all of this together in the sense that we can have a very complex world that we know is going to iterate much faster. So we somehow have it kind of all tied together and ready to make changes, see how they affect the system, et cetera, et cetera.
I really like that observation you just made. And it's really interesting. It's taken me a minute to process it, but the point that digital twins on the hardware side are what is enabling a change of cadence that is what's going to bring the hardware and software worlds closer together in terms of cadence and process. Because, what was a physical prototyping process was a gating factor on that cadence. All right, that's starting to go away. The better the simulation gets, the better the digital twin gets, the faster you go. And now it's like software with continuous integration, continuous deployment. Like, all right, let's do that. So it becomes like digital twin DevOps is what's giving us that capability, right?
Right.
Exactly. And since the beginning of my career, I've tried to expand my knowledge into as many industries as possible. So, for instance, smart construction has been something that fascinated me since I worked in Silicon Valley, especially when, there was the Apple spaceship being built.
Right.
I was not involved, but I was kind of close enough to hear from people. And it was fascinating because the processes that were followed in there kind of resembled the ones in software and hardware, but they were kind of far apart. And in the past 20 years, I see how all of them end up converging. It's just a matter of time, a matter of time, cultural shift, people, getting over their old ways of doing things and overcoming them. It's like, we have to move faster. Even, in construction, there's lean construction to do agile in construction, right?
That's a wild thought to me, agile in construction. But I get it. I get the point, and you're right.
It is. There's a lot of it. They figured it out, but they figured it out their own way,
Right.
So we touched a little bit on AI, but I definitely don't want to leave that completely alone. Can you talk a little bit about what you're seeing, how AI is making an impact in this area of requirements management? I can just imagine it's accelerating everything in terms of how information gets shared. But what about is it driving requirements changes in your view?
Mm-hmm. Absolutely, I think. I'm going to start by highlighting something that I read the other day, and it stuck with me because I thought it was very interesting. That applies to all technologies in the sense that we tend to overestimate the impact of new technology and overestimate the short-term effect of a new technology and underestimate the long-term effect of a new technology, right?
That's interesting. Yeah.
So with AI, it's happening the same. Everybody's like, we're going to have robots destroying humanity.
Right. The jobs are all going to go away. We're going to be done.
Terminator comes to life.
Yeah. And then people are like, oh, wow, no more robots. We're good. So everything is the same, right?
Yes.
Like, no,
not quite.
Not quite. So what I'm seeing with AI is pretty much like from the shift of no internet to internet, or from typewriters to laptops and computers and things like that. Whereas now, absolutely every person has a laptop, right? And therefore, is expected to be at least, 100% more effective than if we only had a typewriter. Same thing with AI. So people will the majority of the people will keep their jobs, but they will have to be a lot more effective. So it started bottom up, and now we're seeing it top down. So organizations are like, okay, this team has to be at least 30% more effective, right? That's what our customers have transmitted us. It's like, okay, so every step of the process has to be at least 30% more effective. From the requirements perspective, we've seen that, or we think that it's going to be one of the areas that will be most impacted and most benefited by AI, because the nature of requirements is natural language, which is the foundation of AI, right? And we see that, for instance, in terms of images and 3D models, it's years behind of what natural language is. So, for instance, in terms of requirements, what we see is that it can do 80% of what an engineer is doing in terms of requirements engineer can be done by AI. But the thing is that it's the 80% that is typically the low-hanging fruit, like copy and paste these requirements, trace these ones that I already know that should be traced, blah, 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 blah. All the part that is kind of boring. And then the engineers have to do like the really innovative part, which the AI is not going to do. So you have a lot more time to focus on, what am I going to do to solve this need that does not exist in the market, right? We cannot forget that AI is just all the knowledge in the internet. They just reshuffle it.
I can access it, right?
Exactly. And then it presents it to you in very nice words. And you're like, oh, wow, this is amazing. It's like, well, yes, it's amazing, but it's just leveraging existing knowledge.
Exactly.
But it's not coming up with new stuff that has never existed before.
Right. I think the thing that I find interesting about that, and like you mentioned with the the 80% and handling the tasks that are really sort of mundane. The part that I find so interesting is the scale piece, right? That AI can deal with, like you said, the knowledge on the internet, that scale, whereas humans, like, we reach a limit and it's like, well, I can look at 10,000 requirements, but by the time I get to the 10,000th one, I don't remember the first 1,000,
Yes,
or the first
exactly.
9,000, that to me is so interesting that where's that going to have an impact for us? But I like your assessment there, Fernando. It's like, yeah, it's going to help, but let's not think that it's going to be too crazy. It's not inventing anything. It's really just helping us do what we need to do and letting us focus on the parts that are unique to us.
Exactly. So what I think the future of product development will be with AI is that, and nobody knows, right? But my idea is that once we come up with requirements, or I'll start with an example. And now there are websites where you can just type in what you want and they will build a website for you, right? So you just say like, I would like a user to register and do this and do that. And boom, you click and it builds the website for you. The biggest concern of users is that the website doesn't do everything that they were expecting. And the owners of the website, they say like, well, if you don't ask for it, it's hard for it to do it, right?
Right.
And I'm like, well, this sounds familiar, right? This is, I've heard this before, right?
Right.
So if you come up with proper requirements, then you could effectively be coming with a perfect prompt to build your system, right?
No, that's an interesting point. Like that's really what prompt engineering is, right? Is it's requirements engineering.
Exactly. Yeah. Exactly. So, for instance, once you have the perfect prompt, you can actually build a first version of your system, right? And of your hardware components and things like that. But then the idea of the engineers is to see the proposed solution and say, well, actually, you know what? This is very organic forms, and it's going to be very challenging to manufacture this because, manufacturing is, not very organic and et cetera. So why don't we do this and this and this and that? And then start adding restrictions to come up with a perfect solution, right? That's where I think the system will be going, right?
No, that's interesting, that analogy between, or that connection between AI and requirements engineering, that's really what we're doing. We'll get the most out of AI, the better we constrain it, the better we inform it. I like that.
Yeah, exactly. And I think the another part which is going to be absolutely fundamental is the fact that the standards are there for a reason, to keep us safe and make sure that what we build follows a certain level of quality. We all know that they are very important, but the cost of following the standards is outrageous as well, right? So some people are like, is this worth it, right? We know it has to be there, but it's hard to assume the cost. Well, I think that cost is going to drop down extremely significantly by the use of AI, because right now, all the tests that we're doing with our own platform with Visure is just like throwing in the standards and saying, okay, build up this requirement specification complying with all the standards. Boom, it does it. It's like, is there anything that does not comply with the standard? Like, well, you're a little bit vague with this and that. Okay, just fix it. Boom.
Right. Yeah. That's back to that scale thing in the mundane, right? It costs us so much now to do that. You have to do it, but can we do it more quickly, right? And can you do it without having to think a lot about it because the AI is doing that for you?
Exactly.
Yeah.
And I have to jump in here and interrupt, fellas, because this has been a fun conversation. I have to be careful of our time and respect our listeners' time as we try to keep our podcast somewhere in the neighborhood of, around 30 minutes-ish. So this is an excellent conversation, really fun. Jonathan, what are your thoughts here? I'm sure you have some interesting summary points.
Well, I think we talked about a lot of great stuff. I'm going to do my best. I've been making notes as we've been talking, Fernando, but I heard a lot of things from the top, where we were talking about these different systems and what are they and are those definitions. I think we were pretty level set on the definitions. But one of the things we got into pretty quickly is, so how do they all fit together, right? And you brought up some really interesting points about requirements engineering really has been matured on the software side more so than on the hardware side. And that's had everything to do with speed. So speed's been a big driver that it's led us to understand how do you do this efficiently. And so there's been more requirements engineering in some ALM platforms, but of course now there are separate tools because you need to deal with both. And this activity of requirements engineering does apply to both. And I think another piece you mentioned is that governance really is where some of the challenge comes in, because you might have different governance models in hardware and software, but you have to think about how requirements fit to both. And that got us into that conversation about systems engineering and sort of blending all of those, right? The governance, the requirements engineering, and then the actual implementation. The architects in the middle, those systems engineers, are thinking about all that and how the whole process is governed as well. So that all those connections, I think, were great. You made another one that I think was interesting about the challenges that we face a lot of times around those differences in speed are about culture too, right? So we've developed these things like silos and interfaces to deal with the fact that, we're running every week on the software side and we're running every quarter on the hardware side or something like that. So those are challenges as we try to bring it back together. Now, okay, how do we get past those cultural challenges? Another piece you mentioned, which is really important, is when you do have that difference of cadence, you have to think about a hierarchy in product development of your governance, of your schedules. Like, how does it all fit together if you're not all exactly on the same cadence? So I guess one more thing that I heard that I thought was really on point and interesting, the convergence of those cadences, that digital twin, and it's the digitalization on the hardware side of product development and digital twins that's going to drive that convergence. Suddenly now we can be closer to the same speed. And that's where I think PLM is seeing that need of, wait, the software world figured out requirements engineering and how this works. Maybe we need to bring that into what we're doing on the hardware side. So I think you really painted a great picture of today why things are separate, why they've evolved the way they have, and how we might be bringing them together as we move forward and what's driving that, so people can have that kind of outlook when they look at their combined cyber products. So last point I heard was on the AI front. Yeah, AI is going to have a lot of impact to requirements engineering, but really in a great way, taking a lot of the mundane away and letting us do things faster, do things more efficiently, and get to the really interesting work. So that's what I heard. I'm sure I missed some things that we talked about, though. Fernando, what did I miss, or what do you think we should share with the audience coming out of this conversation?
No, I think it was a phenomenal summary. I think the ALM and the PLM worlds are merging together. Everybody's trying to figure out what is the best way of doing that. And the only thing that I would add is that every organization will have to figure out what does that mean within their organization that makes between ALM and PLM together, right? So there are a lot of people think about integrating those as well. You just click a button and that's it. But it's a mentality, systems engineering mentality. Companies like SpaceX have done a pretty good job at making sure that everybody's thinking from a systems perspective, not just hardware or software. And that means that every step of the way is integrated, right? So, we have the billing of materials, but then we have the software billing of materials, right? As something that will become more important. So there are multiple different levels of integration.
And you just reminded me of something that I did not summarize that I should have, that you added in today that I think was really important. And that's, okay, RE, ALM, PLM, don't forget MBSE, right? Yeah. Because systems engineering, we mentioned that it fits amidst all of them, but it's now really a key piece of that digital puzzle. And it fits into those three. It's kind of that fourth piece we need to think about as we bring them all together.
Yes, correct. And it's very exciting to see all these changes, right?
Absolutely.
Be part of them. And the last thing that I wanted to mention is well, I think we're heading towards the end. I would like to thank you for hosting this phenomenal, super interesting chapter. I think everybody is super in tune with this ALM, PLM world integration, and thank you both of you for hosting me.
Yeah,
thanks so
absolutely.
much for being here. We love having you as a guest, and we'd like to keep the door open for you to come back another time. I'm sure there'd be more interesting conversations we could have.
Absolutely.
Absolutely, yeah.
Yeah, that'd be great. That'd be great.
Like how AI took over the world and we couldn't know.
Yes, we could.
How we missed it on this podcast.
Exactly. That's great. Well, I appreciate everybody's time. Jonathan, thank you. And Fernando, thank you. This has been fantastic. And to our listeners, if you have any questions for Fernando, please put them on the post or just leave us a comment. We'd love to hear from you. And please make sure to give a like to this episode if you enjoyed it. And with that, we are going to close out today's episode. But as always, we ask you to stay sharp.
Thanks,
everybody. Have a good day, everybody.
Thank you, everybody.
Thanks for being here and listening to this episode of Stay Sharp with Razor Leaf. If you like this podcast, please be sure to hit the like button and subscribe to our podcast on your favorite podcast platform or watch us on YouTube. If you have any questions for Fernando, please leave us a comment on our post or just send us an email at podcast@razorleaf.com. Until next time, everybody, stay sharp.